Hi there, and thank you for tuning into the JIT Company's YouTube channel, the channel for all things related to lean, just-in-time manufacturing. My name is Rob van Stekelenborg, and our mission at the JIT Company is to help you create and sustain flow in your supply chain. Now, in this video, I'm going to demonstrate our Single Item Demand Profiler, or SDP application for short. Now, there is no one-size-fits-all value stream or supply chain strategy, I think. I think your approach should depend upon your context, and one of the main factors to consider is the profile of your market demand. And there are 4 demand characteristics I think that you should consider. And these are volume, meaning the quantity required by your customers, the variability, meaning the amount of fluctuation in demand volumes over time, frequency, or probably better the interval with which you need to supply your market, and lastly urgency, by which I mean the time that your customers allow you to supply them. Now, with SDP and its companion multi-item application MDP, you will learn how to analyze these aspects in depth and with just one click. Now, I will leave a link to both applications in the description below, so you can check them out. But now back to our Single Item Demand Profiler, or SDP. Like many of you out there, I guess, I've been developing Excel workbooks and Access databases to get my head around the demand pattern of a certain product. And at one moment I thought, well, let's put this experience in a more professional application and make that available. I use this application myself in my client engagements, and I can tell you it saves me a ton of time. So without further ado, let's jump in and have a look at SDP. And by the way, if you like our stuff, please subscribe to our channel to not miss out on any future videos. When you download the application from our shop, you will get a zip file with the application and a short manual. And after activating it, you should be ready to go. Now, let's fire up the application then. When starting the tool, you will have the option to either start with a new workbook or to open the application with a previous dataset. And now, for our demonstration, we will start with a clean sheet. So I'll click Original Workbook and the application will further start. Now, the first thing when you're opening up the application that you will see is the work standard for the tool. This work standard provides a clear and visual instruction on how to use the application in a TWI based fashion. And I recommend to familiarize yourself with the steps, but you will notice it is quite self-explanatory. Let's go to the meta worksheet. To start a new demand pattern study, I will first put in some metadata or data about the study itself. So here I enter the site or the plant. So let's call this plant A. The item that we're going to study. Let's say I have an example of some metal coils with the same description. The process where this product is made is finishing. Now, the unit of measure is important. These coils are being measured in terms of kilograms, and I will come back to this factor for the takt time later on. And on the right hand side you will have the opportunity to enter the date, your version of this study, and your name. Let's put in my own name. Now let's come back to this factor for the takt time. As you can see, the application is also fully annotated. Now, the takt time factor is to be able to translate your unit of measure into a unit which is relevant for your takt time. This is sometimes required in more process-oriented industries where demand volume, for instance, is specified in tons or liters or kgs in this case. And the company actually sells packaged goods that contain a certain fixed or let's say average amount of this unit. And in this first example we will look at, this is in fact the case. And in fact they sell their metal at an average packaged volume of 8,500 kgs. You will see that coming back later. Now let's go to the data you need for the analysis. So we'll click this button here, go to data. This will bring you to the data entry sheet. In this worksheet you can enter your order line data that will be used for the analysis. You will need the order and order line ID and the entry request first promise, and if it's already shipped, the actual delivery date, and of course the quantity of that order line. Now for this demo I have a few real life data sets ready that we can use. So let's take our first example for these metal coils. So here you can see the data. I will select it. I will copy it with Ctrl+C and then right click here and paste it while matching the destination formatting. And then the only thing that is left to do is to press run. Now SDP performs demand pattern analysis on two levels. The first one is at the level of the order line. But order lines can of course be required to be delivered on the same request date. Therefore SDP also analyzes demand patterns at the date level. You will see that this is not the same, although it's something that will not pass through the minds of most people, I have noticed. Now let's first have a look at the order line data, and let's go to our demand quantity at the order line level dashboard, which is the first one. In this dashboard we focus on demand volume. Now as you can see, the data set has 33 data points for order lines and a total of around 285,000 kgs or 285 metric tons of metal required over a period of 432 days. Then in the dashboard itself, the first row of charts, this visualizes your demand process. It shows the demand quantity, order line by order line, in the sequence of the order lines, the distribution of the order line quantity, and the summarizing box plot. And below that, you can see a summary based upon statistical process control principles. I won't go too much in detail here as it is just a demo, but you can find all the key statistics about the demand pattern, like the mean, median, how skewed the distribution is, and much more. So here you can see it's slightly skewed left with a few low points and even one that is out of your control limits. Here the first one that you could have already identified also in the moving range chart, which indicates the order line to order line shifts that are happening in your pattern. You can also see some key data related to the variability of your demand. In this case your demand is quite stable, which you could have already seen from your run series chart, which is confirmed by your SPC or process behavior chart. You can see here it has a coefficient of variation or a relative standard deviation of only 7% and a stability factor of 0.94, which indicates this is really a very stable demand pattern. To the right of that you have a similar dashboard, but now this one is focusing on the demand intervals. So the frequency with which we are confronted with demand at the order line level again. At the top now you can see the takt time based upon the 8.5 ton saleable unit. So on average we have a takt time of almost 13 days for each individual saleable unit of around 8.5 tons. Next you can again see the visualization. So this is now the interval with which order lines are requested. And you can already spot a few strange points here, particularly this one of course, on the 3rd of April. And you can see that coming back also in the distribution and in the box plot. So you clearly see there are some strange things happening here. Below you can again check the SPC evaluation of the demand intervals. You can see that the median of the demand interval is 7 days, as you can see here. And of course these outliers, they pull up the mean demand interval up to almost 14 days. Now the interval and the volume variability can be combined in a matrix chart that characterizes the item. You can see that on the next chart. So this is a very nice chart to understand a little bit where this item is positioned. So you can see here it is in terms of variability, it is really quite smooth with a relative standard deviation of only 7%. And on average it is required on a bi-weekly basis more or less. And you can see this is even pulled up from the weekly level due to only 1 or 2 outliers. So probably it's more in this range. So this is of course important to know when you want to develop your strategy. So in fact this item is a good candidate for a make to stock strategy, probably controlled with a pull system. But with still some work to do to find out what are the causes behind these 2 outliers, particularly the one early April. But now let's have a look at the same data, but from a date perspective. Because some of the order lines that we've seen now can of course be requested on the same date, recreating a different pattern than you might suspect from the order line perspective. Now to evaluate that, we'll go to the next dashboard, which is the order quantity, but at the date level. Now here you can immediately see what I mean. Apparently in the first few months leading up to that order line gap, by the way, order lines were grouped together on a few dates, creating far larger demand peaks on fewer moments. Now, in fact, this investigation led to an immediate policy change at that moment, in which customer orders were immediately more leveled when we found out this practice. And as of April-May, around that time, demand patterns became more stable, making it, of course, a lot easier from an operations and supply chain perspective. Now, instead of continuing with this example, I also want to show you another example quickly. So let's go back to our meta sheet and show you how we can empty our data. So here there is a button and a shortcut Ctrl-E. I will push the button. This will empty the whole sheet and we can start our new analysis. You can of course also save these ones and reload them later. Now we'll again put in the descriptive data for this case, which concerned an equipment manufacturer of highly configurable machines. So we'll enter the site, plan B. We'll have a machine 1, item description, machine 1. The process where this one is being made is the assembly process. And we've got a unit of measure, which is a unit, and we put the factor for the takt time back at 1. We'll again put in the metadata for this study, and I'll put in my name. Again, we'll go to the data and we'll put in our next example. So here I'll again copy all the order lines that we've got for this example. So as you can see already, there's around 350 order lines. I'll paste that in and click run. Now let's again have a look at our order line demand volumes. Now as you can see, there's nothing wrong by the way here. This is quite different. As you can see, all 354 order lines that we got in this data set in around a year of data, they were exactly for one machine. In fact, it's not so surprising if you understand a little bit the context of this manufacturer, because these machines were relatively costly and for quite a specific purpose in fact. But now let's have a look at the date level demand variability. Now here you see the picture changes somewhat. There's more variability than maybe required if we would only be able to level our demand over time. Yeah? Interestingly enough, when we investigate these out of control data points that you see here popping up from time to time, we found out that most of these peaks were related to orders coming from their own sales organizations instead of their direct channels. So here again, it's a good example of looking at the two perspectives when evaluating your demand patterns. Now to go to the last part of this video, let's have a look at the few dashboards that we haven't seen yet. Let's look at the intervals, the demand intervals, but now at the date level. So not order line to order line, but date to date intervals, which is also part of SDP. As you can see, the takt time for this product is 1 day, but you can see that the average, the mean, in reality is 2.2 days, with a median of 1 day, again due to the right skewed distribution, with gaps up to a week in the demand interval. Yeah, so sometimes we got a few days of no demand, and then but most often it's every second day, and the median 1 day even. Again, we can characterize the demand pattern, but now not so much in terms of the order line, but you can also do this based upon the date level demand data. Now, for instance, you can compare the two to see the impact of the batching on certain dates. Particularly in this case, for instance, here you can see it is extremely well positioned, this one, to think about the strategy. It's really daily, in fact, with no variability at the order line level, as we have seen. But if you look at what we actually do with it in our behavior, in our practice, we can see it's still quite stable in terms of volume. Yeah. Still very regular, but due to the batching, we have increased tremendously the demand pattern in terms of volume, and it becomes, instead of being potentially an extremely smooth demand pattern, we've made it into an erratic demand pattern due to our own batching over time. Now, the last section that we haven't seen yet, the last two dashboards, deal with lead times, and we try also to answer the question of how urgent our customers require us to deliver our products and how well we are dealing with this. So let's have a look at these two before we wrap it up. First, we'll go to the lead time dashboard. So here, this dashboard first shows you the required lead time as specified in the order line. So here you can see the average is some 10 days. Yeah, the mean requested lead time is 10 days, with a median of 3.5 days and even a mode of 1 day. Now, this is of course quite a challenge, 3.5 days with a mode of 1 day, knowing that this concerns a configure to order manufacturer. Yeah. Next on is what this company actually promised their customers. So where the median of the requested lead time was at 3.5 days, if you go down, this is what we actually promised our customers, is at 20 days. It's probably more realistic, knowing that they were assembling to order, but it does tell you something about what the market really wants and what this company is currently able to promise. Now, and lastly, you can see that the actual lead times, the median even further goes up to 23 days. So where the median requested lead time was 3.5 days, we promise at a median of 20 days, and we actually deliver our clients at a median of 23 days. And all three have quite some variation, as you can see. All in all, this already gives you a certain feeling about the challenges facing this company, particularly also when we've seen that the demand at the order line level, in fact, was so stable with a takt time of a day. Now, the last dashboard that SDP proposes is about delivery reliability. In fact, this combines the lead time data we just went through. So let's check that one out. Now, the on-time delivery reliability of SDP provides the user with 3 overviews again. The first one is the performance when comparing actual delivery date versus the request date. Now you can see from the plots here there is quite some spread around the request date in the middle, and you can see that also in the box plot, and you can see it leads to an average or a on-time performance versus request, actual versus request, of only 2.3%. Now instead of talking about the percentage on time, I in fact prefer always to speak about the spread of the performance. For instance, summarized in the span. Now the span you will see here is at 52 days. Now span is the middle 90% of the distribution you see in this middle chart here. So in fact it is a measure of the total spread, leaving out the extreme 5% on the lower and higher ends. So to learn more about this, I will leave a link at the bottom where you can read more about how to properly measure delivery reliability. Now for this item, as we've seen, the span is a massive 52 days. So to be honest, this is not good. Now the second set of charts that you can see below then goes into our promising behavior. It compares our promise versus the request date. Now you can see here that on average we promise our deliveries 12 days later than they are requested. And again with a lot of variation. It doesn't show a very consistent behavior in fact. Something customers might not really appreciate, of course. Interestingly enough, we also sometimes promise to deliver our customers earlier than required, which you can see in the graph here. And the values here that are negative. So we do have quite some cases where we promise earlier than requested. Enough insights, I guess, to start up some good discussions on the way we manage our supply chain. Now lastly, we look at our performance, our delivery performance against our promise. Now luckily enough, despite the percentage still being only at around 5%, as we see here, the span at least is far less at around 15 days. So still not something to be truly proud of in my opinion. So this wraps up the overview of SDP. As you can see, with the push of a button you can create a very powerful and insightful set of dashboards based upon just your order line data. And these insights can then help you in discussing the right way of setting up and managing your value stream and supply chain. I hope you've enjoyed watching this video and hope you found it useful. Please let us know in the comments. Now, if you would like to know more about the JIT company, please do visit our website at thejitcompany.com for more. Here you will also be able to find the application we have demonstrated in this short video. You can find the exact link in the description below. And I also strongly recommend checking out the multi-item companion application MDP. This one allows you to create similar insights, but then for a whole product portfolio and up to 25,000 order lines with just the click of a button. For now, thanks for watching. Please leave your comments below, and I would very much appreciate if you would like this video or subscribe to this channel. And then we hope to see you back in one of our next ones.